Hi everyone, my name is Charlie. I'm going to talk to you about transforming retail with Go, which is quite a grand title. I know I'm the only thing between everyone and a beer, so I'm going to keep this fairly light. I move around quite a lot as well while I'm talking, so don't get distracted by that. So I'm going to go through a little bit about Sainsbury's, a bit about when we use microservices, and also why Go is such a great language for microservices in a large organization such as ours. So first of all, a bit about me. I'm a software engineer at Sainsbury's, if you hadn't already guessed. I've been working with Go for 2 to 3 years now. If you've got any questions after the talk, you don't manage to catch me afterwards, then please send them on Twitter. So kind of Sainsbury's in a nutshell, we are the second biggest grocery retailer in the UK, 1,300 stores, around 15 to 25 million transactions per day. We have a bank that did around 236 million transactions last year. We also have a clothing brand called Two. So the position that Sainsbury's finds itself in at the moment is one of quite radical change. As you may have heard, the retail industry at the moment is very challenging and it's very competitive. And the way that people are shopping is changing quite dramatically as well. So one of the things that we're kind of doing to respond to this is really to adopt a tech-first strategy. So what does this look like? Well, for starters, we want to move quickly. So we obviously want to deliver value quickly to our customers, but we also want to find out what works and what doesn't work quickly. So we don't want to be thinking about stuff for 6 months and then find out actually the idea doesn't work. We also want to move very quickly to how people are shopping. So people generally don't shop in big shops anymore. It's little and often. So we need to respond. We want to respond quickly to that. This very much fits in with our change from a very waterfall-based company to an agile one. I wouldn't say that this process is complete yet, but we're certainly on the right track. We've also changed the way we do infrastructure quite dramatically. So we've gone from very much on-premise solutions to a cloud-first strategy. So everything new we do goes into AWS. We work in small teams. So these teams have a flat structure. They have technology freedom. So developers can choose which technology fits the problem the best. And they very much own what they build. So they're involved pretty much from inception of an idea or a feature, and they then, at the other end of the spectrum, support it in production. So over the last 18 months, we've scaled our development team quite dramatically. So it's gone from 12 developers to over 300, and that's across 3 sites, Coventry, Manchester, and here in London. So microservices. I'm sure everyone's really thrilled to hear another talk about microservices. But hopefully I can add a little bit of value. I'm going to kind of tell you my personal thoughts on when you should use them and when you shouldn't, and a little bit how we use them at Sainsbury's. So normally, I suppose at this point, you would guess that I would be telling you how great they were and how you should adopt them in your company. But just for a moment, I'm probably going to do the opposite. Because for me, microservices are a real pain. They really are quite hard to do. So I picked this guy for this slide because he looks what I imagine to be like a guy who works in a startup. And obviously, at Sainsbury's, we're not a startup. We're kind of the opposite of a startup. And you might be thinking now, why is he mentioning this? What on earth has this got to do with Sainsbury's or microservices? And it's really around the business domain. So at Sainsbury's, we have very kind of mature parts of our business. So we have our groceries platform, for example. We've been doing that for a long time. We know that business domain quite well. Whereas we also have new ideas, new apps, new businesses even that we actually develop in a silo. And these businesses are effectively like startups. And in a startup environment, you don't really know your problem well enough yet. And if you dive into microservices too early, you have to start defining your contracts between your services. And then if you want to change those, that really becomes quite painful. So generally, when people talk about the problems with microservices, generally network latency comes up quite high up on their list. I kind of disagree, and I think network latency might not even make it into my top 5. As most of you know, I'm sure you know, most of the latency that you'll have is kind of going to be around your data stores. Especially in Go, we're not going to have that much latency with a language like that. The biggest thing for me is planning for failure. And that you've got to do pretty much from the start. And what's worse than failure is part failure. Even more difficult to debug, even more difficult to handle. So this fits in with networks. So networks generally are really unreliable. You'll have random network partitions, random TCP retransmission errors, and generally the more machines you add to your stack, and if you are writing a distributed system, you're generally going to be adding more machines, the more chances you have that those machines will fail. So you have to be able to handle this right from the start. Automation is pretty much essential. You can't really get around not having automation, and that's quite costly to set up at the start. You have to be really careful with dry. So, as developers, we like to write reusable code. We don't really like to have duplication all the time. And when you look at a distributed system, you think the same thing. So you develop service A, and then you develop service B, and then you develop service C. And you think, well, I've written a lot of stuff in service A that I'm writing in service B, so why don't I just put it in a library and then include it in both? But then you've kind of coupled those two services together. You've linked them. And in my experience, I would always suffer the lesser of the two evils, so being dry being the worst of the two evils, if you see what I mean. So generally, microservices are polyglot, so you can write them in any language you want, which is great. But the more languages you add to your stack, the more complex your stack becomes. Also, debugging becomes more complex. So if you have a request that hits your infrastructure, and then it takes 4 or 5 hops through your infrastructure, that potentially could be 3 or 4 hops through different languages. So then you've got to debug in 3 or 4 different languages. So I've gone through the doom and gloom the way I see it. So why should you bother? Well, for starters, you can deploy them in isolation. And I suppose as developers, we've all been in a situation where we we've edited this code on this huge system, and we've written all our unit tests, we've been good developers, and then it comes to deploy it, and obviously it's a massive deployment because we're deploying the whole thing, we're not deploying a little bit of code. And our finger hovers over the kind of deploy button, and we think, I'm not really sure how this is going to go. Because we're really not sure what areas of the system our code might have accidentally covered, or we're not really sure whether some other team has written a library like 3 months ago, which actually we've introduced a bug in accidentally. So basically, then as developers, that reduces our confidence. So we start to deploy less. Deployments become a big deal. And as soon as with distributed systems, you remove that. So you can just concentrate on an isolated part of your system. And what that means is you're more confident to deploy. It means that you can do things faster. and suddenly that you're deploying maybe a couple of times a week, or maybe even a couple of times a day. And that's probably what we all should be aiming for. So they promote encapsulation. So you can easily hide databases, implementation detail, config. You can scale them on demand. So you don't have to scale your entire application. You can just scale individual services kind of as needed. And probably the biggest thing for me is they lead to mutable software, which is what we all kind of want. Like, we want to work on software which is evolving, it's changing all the time. We don't want to be working on stuff which is kind of stagnating. And microservices give us that. It builds confidence, our confidence in our own software. The more we deploy to prod, the more we're confident about our software. So a quick kind of when and when not. So I wouldn't treat them as a silver bullet. They definitely won't solve all your problems. In fact, they'll probably give you more problems than necessarily they'll solve. If you're unsure about your business domain, or you're starting a kind of new products in your company, or you're working for a startup, as guy we saw earlier, then I would definitely consider building a monolith. And what you can do is you can take a little bit of a hybrid option. So if you want to do kind of both, you can look at designing a monolith in a way that is almost like mini services without a network. And you can do that with libraries. And then when it comes to you want to feel more confident about it and you want to dive in to distributed systems, you can then just, your libraries become your new services when you put a network between them. If you are planning to dive in and do what everyone's talking about, then I would, probably number one thing, I would definitely design for partial availability. So as I mentioned earlier, failure is going to happen, kind of whether we as developers like it or not. So when failure happens, the most important thing is we return something. So whether that be some stale data, or whether that be, in worst case scenario, just a status code. So if you have to fail, do it quick. So why is Go such a kind of great language for these microservices? Well, I'm probably preaching to the converters slightly at a Go conference, but our language is really small, so it's really easy to get productive very, very quickly. And in a large organization such as ours, with a lot of developers, that's a big benefit. And it sits very nicely with our very small services. So new developers can understand the code base very quickly, and in Go, they can become productive very quickly. Static linking. So you can compile a binary, and you can put that on a Scratch container, and it means your containers are half the size that they would be otherwise. Moving big containers around a system is really quite difficult. So tooling that scales. So we're all familiar with the tooling that Go gives us, but especially for us, being able to have a tool in the language which formats our code gives us a massive head start in standardizing our Go code across a large amount of developers. I mean, you try telling 300 developers that they need to use tabs rather than spaces. So that gives us a big head start. So when I first started writing Go, it was on a distributed system, not at Sainsbury's, around 20 to 30 services. And at that point, there really wasn't a lot of libraries out there to help you with the kind of heavy lifting, or what I call heavy lifting, to do with microservices. So things like networking, service discovery, transport, circuit breakers, tracing, monitoring, all of these things that you have to kind of do as soon as you embark on these things. So we kind of had to write all of ourselves, with varying degrees of success. Whereas now, we've had some really great developers, great organizations that have kind of released a lot of this stuff, their battle-hardened stuff, to the community. So you've got Micro, which Asm talked about earlier. You've got GoKit, which Peter talked about yesterday. You've got Kite, Gizmo was released by the New York Times. and Typhon is Mondo's new RPC framework. I may have got that name wrong. Sorry, Mondo. So I'm going to show you a little bit of an example of a system we might build at Sainsbury's. It's not an actual system that we've built. It's a kind of example of what we might build. So the scenario we've got is that we want to display a real-time stock level on a web interface. And for that, we're probably going to use WebSockets. And we've got a stock API, which is a JSON-based API, which basically accepts the socket connections. And that's really only going to be that's kind of the edge of our little infrastructure here. So, and that's really the only point where we're going to deal with the JSON. Everything behind that is going to be with RPC and protocol buffers. So this is quite a common pattern now in a lot of companies. And the reason for it is that as soon as you start to scale out into kind of 3 or 4 or 5 or 10, 15, 20, even in some cases, hops around your infrastructure, marshalling in and out of JSON is really quite expensive. So a protocol buffer is basically you're compiling your data into a binary format, and that's just a lot cheaper over the wire. So if you haven't looked at protocol buffers, I would definitely suggest doing so. So kind of leading on from that, we have the stock service, which does exactly what you'd imagine it does. It updates stock. And we have the payment service, which connects to kind of some legacy system. And the payment service sends an RPC call to the stock service to update a particular SKU, and the stock service will update its record of that stock level, and then publish the event onto a queue. The stock API will be listening on that queue, and then it will handle the event by sending it back to the relevant WebSockets. So for these services, I've chosen to use Micro. At Sainsbury's, we're technology agnostic, as I said before, so teams are using lots and lots of different frameworks. Too many to go into, I think. I'm not going to go too much into how you use Micro. If you want to kind of know more, then please see Azam's repos. And I'm really going to focus specifically on the stock API bit, and very specifically on the library, which is basically handling the events and then distributing those events back to the right sockets. So, bit of code. To start with, that top bit is basically what you'd put in your initialization of your service. So you get a handler back, and you basically call init on that method, and it will start everything up. So start listening on the receive channel, which you see at the bottom of the screen. Now, this is where you would take something from the queue, and you'd pass that event into that channel. Now that, in my case, is coming from a queue, but it doesn't have to be that. It could be an internal event of your service. It could be an event on another machine. It could be anything, really. At the end of the day, it's just a struct. Now, this code would probably sit in your handler, so your actual stock handler. So it would get called when a new socket actually connects. And you'd create a connection struct. The reference is just what you're referencing from the sockets compared with the events that you're passing into the receive channel. So in my case, I'm using a SKU. And the second field on that is actually the WebSocket itself. So I've used Google's WebSocket library for this. You then pass that into the register event method, and that tells the library about that socket and what reference it's listening for. The channel at the bottom is just listening for if the library tries to write to a socket and there's an error, or the client disconnects the socket. So the new handler itself makes the receive channel, accepts an event, and the second one is the store, so where we store this information. So we want to store this in memory. We don't really want to be writing out of this stuff to disk. So the key to that is the reference, which is just a string, and then there's pointers to the connection itself and the connection struct that we passed in at the beginning. So the init method itself, again, very, very simple. It's just listening for an event on the channel and then broadcasts it twice. The reason it broadcasts it twice, it broadcasts it once for the actual reference that's inside the event, and then it broadcasts it again just in case people are listening to all events. The broadcast method itself, again, very, very simple. Just marshals your data into JSON, loops over the store for that particular reference, and then sends that data back through the socket. And that's pretty much it in under 90 lines of code. So these are the repos which I've for the examples. I've used Rabbit for the queue, Cassandra for the data store, and Consul for the service discovery. However, you could pretty much use whatever you like there. Micro allows you to kind of swap these things out, as do most of the other libraries you can use for microservices. And there's no payment service. So if you feel like writing a payment service to add to this example, it would be very much appreciated and would be quite interesting. And that is pretty much it. At Sainsbury's at the moment, we are hiring, as you may have guessed from our huge stand out there. So if you fancy kind of writing Go for a supermarket, then please see me afterwards, or you can apply on our website. Thank you very much.